Okay, well, let's see. So here, if we do this, we would have to do P of n is equal to a sub 0 plus a1 x minus c plus the second, the a2 and a3, all these here. Now we're going to take our derivatives, okay? So here, if we did P1, Pn prime of 1, Pn prime of x, that's equal to a1 x minus, actually not x minus c, just x, because the derivative of x minus c is it's not actually not even x. Sorry about that. That's just going to go to just 1. So just a1, okay? And so now we have a1 plus, now to the derivative here, 2a2 of x minus c. Okay. Oh, a1x. Sorry about that. No, just a1. Sorry. It's a little bit nervous. Sorry about that, ladies and gentlemen. So yeah. So it should be a1 plus 2a2x minus c plus 3a3x minus c cubed all the way to an times n x minus c to the n minus 1. Okay, and now here Pn double prime is equal to, now this, take derivative of this one here, plus dot dot dot, of course. So we'd have in this situation, well, a1 drops out as a constant, so 2a2 times the derivative of the x minus c is just 1, so we have 2a2 plus here, this would be squared, sorry ladies and gentlemen, this should be squared, not cubed. It should be a squared here, okay? And so then we have 2 times 3 a3 x minus c to the first power, plus, and then continue onwards, we'd have an times n minus 1 times x minus c to the n minus 2. And maybe we start seeing a pattern. We continue with p, the third derivative of this situation here. We'll get 2 times 3 times a3 plus, in this case, 2 times 3, 2 times, I guess we could keep going on. I have the previous one here, so that would have been in this case, if it was a the third. Sorry, ladies, I'm to move this up a little bit. If we had in this case, I should have done a to the third. Ooh, sorry. So we did a to the third, so okay. So what it comes down to is it continues further, and so we'll end up getting 2 times 3a to the third, and then all this will just continue onwards to get, in this case, an times n minus 1 times n minus 2 times x minus c to the n minus 3. And so when we go all the way to the nth derivative, we're just going to be left with, in this situation, we're going to end up with a to the n times n factorial. Okay? So what comes down to is that's just what we get. All right? So now, because the value f and its first derivative n derivatives must agree with the value p of n and its first n derivatives at x equals c, it means that f of c should be, in this case, the first term a0. F prime of c will be a1, and f double prime of c will be, f double prime of c over 2 factorial will be a2, and f2 prime of c over 2 factorial will be a3, and fn of c, and fn factorial c over n factorial will be the anth term. Okay, so So we just, and this is, well, why are we doing all this though? Okay, well, the idea now in this situation is that we're going to use these here, okay? And from here, these now become coefficients for what we call Taylor and Maclaurin polynomials. Taylor and Maclaurin polynomials. Okay, so let's get to some more definitions here. All right. So we have our definitions of nth Taylor and nth Maclaurin polynomials. If f has n derivatives at c, then the polynomial Pn of x is equal to fc plus f prime of c x minus c plus f double prime of c over 2 factorial x minus c squared, all the way to f, the nth derivative of f of c over n factorial times x minus c to the nth power. So this is the form. Okay, so what it comes down to is this is going to be the form for the nth Taylor polynomial at C. Okay, so now we have almost a formula to plug into if we want to find a Taylor polynomial at a particular value. So for us, we're just going to find really just the f of c, f prime of c, f double prime of c, all the way to the nth derivative of c. Then we're going to just plug the rest into our formula. And if c equals 0, this is a special formula where p of n of x is equal to f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x squared plus f triple prime of 0 of 3 factorial over 3 factorial x cubed, all the way to the nth derivative of f of 0 nth factorial of x to the n. This is known as the nth Maclaurin polynomial for f. Whew, that's a lot. So let me put this full screen so you guys can see. Okay, so these are forms we're going to use. These are the forms where we want, if we're asked to find a Taylor polynomial or Maclaurin polynomial, these are the forms we're going to use. And the only things we really need to know how to do is to find the function and its the particular derivatives up to the nth polynomial. And then why do we do this again? We're approximating these functions that are not polynomial functions in a polynomial form. All right, so we have a special one that only works at c equals 0. That's our Maclaurin polynomial. And we have a special, everything else when x equals c will have a Taylor polynomial. Okay, this nth Taylor polynomial has this form here. All right, so if we expand our first question, the nth Maclaurin polynomial of f of x would be just p of x is equal to, I'll make this page big again. So we expanded our first question. The nth Maclaurin polynomial for f of x equals e to the x would be p n of x equals, the nth polynomial will be 1 plus x plus 1 over 2 x squared plus 1 over 3 factorial x cubed plus all the way to 1 over n factorial x and x to the n. Now why is this the case? Because, well, every derivative of the function f of e to the x at 0 was just 1. So we just filled in 1 for the numerators. Okay, but we know it gets a little trickier. Okay, so here we go. All right, so we're going to start here. And so now let's find the 4th degree Taylor polynomial for f of n equal f of x equals Ln of x centered at c equals 1. Okay, so we need to do, again, we need to find the values of the function as derivative at c equals 1, not c equals 0. So for example, we will have f of x equals Ln of x means f of 1 equals Ln of 1, which is 0. F prime of x, derivative of Ln of x is 1 over x. Therefore, f prime of 1 equals, well, 1, because 1 over 1 is 1. The double prime would be, in this case, negative 1 over x squared. The derivative of 1 over x is going to be negative 1 over x squared. And if we substitute 1 for x, we get negative 1. And we continue here. F triple prime of x is equal to 2 over 3x cubed, which means in this case, f triple prime of 1 is equal to, well, 2 over 1 cubed, which is just 2. Go a little further down now to our 4th derivative, because we're in a 4th polynomial. So our 4th polynomial in this case is going to be negative 2 times 3 over x to the 4th. Well, that's, now why did I do that for? I basically wanted to make sure you guys understood that it was going to be this whole idea of this, what we're doing is we're getting this, almost like the ideas that we just taking derivative of negative 3 here. So really should be negative 3 times 2, which is negative 6. So negative 6 over 1 is negative 6. Okay, so now we have these coefficients, these numbers of, in this case, of f of 1, f prime 1, f double prime 1, f triple prime 1, and f quadruple prime 1. Okay, and so now we're going to fit into our form. Oops, sorry. So our form in this case is going to be here. P4 of x equals f of c plus f prime of c times x minus c plus f double prime of c times x over 2 factorial times x minus c squared plus f triple prime of c over 3 factorial times x minus c cubed plus f quadruple prime of c over x minus c to the 4th power over 4 factorial. Okay, so all we're doing now is replacing our f of c, f prime of c, f double prime of c, f triple prime of c, and our f quadruple over c. Also replacing c with 1. All right, so we'll see here. We'll get, all right, f of 1 is equal f of 1 plus f prime of 1, x minus 1, plus f double prime of 1 over 2 factorial times x minus 1 squared, plus f triple prime of 1 over 3 factorial times x minus 1 cubed, plus f quadruple prime of 1 over 4 factorial over times x minus 1 to the 4th. And so here, we just plug in the values and simplify. So here, f of 1 was c, f prime of 1 was 1, f double prime of 1 was negative 1, f triple prime of 1 was 2, and f quadruple prime of 1 was negative 6. And we simplify here with our factorials. We are going to get, in this situation, P4, the 4th polynomial, will be x minus 1 plus negative 1 over 2 x minus 1 squared plus 1 over 3 x minus 1 cubed plus negative 1 over 4 x minus 1 to the 4th. So we're just finding our coefficients. The coefficients really help us out because we have the same generic, or not generic, but same pattern we're using for our polynomials here. Okay, so this is where we're going to end. I actually going to have to break this video up to pieces. So hopefully it's helpful. I will probably do some more practice problems after this to help out if you have questions. You guys are really bright though, so I know you guys won't have much trouble. I'll make this full page so you guys can take a look at the whole thing. All right. Hopefully that helps out. And so I'll see you probably in the next video. We'll do a few more practice problems, hopefully help you out with the homework I'm going to assign. So this is our intro to the nth Taylor polynomial and the nth Maclaurin polynomial, and the use of these polynomials to approximate functions that are not polynomial functions around a particular value of c. Okay. If you found this helpful, I mean, it was very much straight from textbook, but if you found this helpful, please give us a like, leave any questions or comments below. If I've made an error, please let me know because those happen. But I appreciate you guys watching, and hit the subscribe button for future updates of any videos. I am posting both my geometry and my calculus class videos up at this point. So if you want to know when a notification, subscribe to my channel and hit the notification button to know when any of my videos drop so you can see. All right, but I'll post on the Google Classroom as well. Thanks everybody. I will see you soon. Take care and be safe.